minimize your surface, so you want your surface area, don't use too much material, right? And at the same time, or you're going to maximize your volume, okay? So the purpose of optimization is to minimize your surface area and to maximize. You can either do one or the other. You can't do both at the same time, okay? Technically, they should say or maximize the volume. There's actually one like whole course in university about optimization. It's a course by itself. It's a fourth year course in university, okay? That only deals with this, minimizing, maximizing. Okay. Rectangular prism. So when we dealt with the what was the optimal square? Square is a rectangle, right? Square has four sides. The only difference between a square and a rectangle is that it has four. Square is one side of the rectangle. Okay? So we figured that the square is okay. Now if we're looking at 3D rectangular prism, what would be your optimal state? What is a cube made of? How many? 6, right? So looking at a rectangular prism, right? If you want to optimize that prism, you want a square for each side, which makes it a cube, right? So similarly to the 2D object, right? If I want to optimize that rectangle, I have to make it into a square. If I want to optimize that rectangular prism, I want to make it into a square. So that cube is going to use the least material possible, and that's going to give you the weighted volume possible. Okay? So anytime the question says optimize with a rectangular prism, you're looking at a cube. Okay? So you're always looking for that word, what's optimal or is the maximum or what's the minimum. You're looking for these special words, okay? So, when we are dealing will always be that of a so if I'm looking at a cube, okay? So I'm looking at a cube. All the sides in a cube are equal, right? So do I need to call this length and this with names? No. I can call them the same. I can call them A, or S, or whatever, right? They're all the same sides, right? So the surface area is, you find the area of all the sides and add them together, right? But we know that the area of this face, the area of this face, of this face, this face, they're all the same. So basically I have 6 equal faces. Do you agree with that? So this side is S, and this side is S, because they're exactly the same, right? What would be the area of S squared, right? S times S gives me S squared. 6 of them. What's my surface area? 6S squared. So instead of using the rectangular formula, right, which you have that in your purple sheet, I'm going to have to use the cube formula for the surface area, which is 6S squared. So anytime I'm dealing with a rectangular prism with a surface area of a cube, which is 6s squared. Okay? So, since the length we refer to all the sides with the letter S, and then because this is S, right? So if I'm looking at the surface area, I have S times S, which is S squared, and I have 6 of them, so that gives me 6S squared. Are we clear with that for the surface area? Everyone? Now, volume of a rectangular prism is length times width times height, right? Of a rectangular prism. It's in your purple sheet. In this case, I don't have length, width, and I have S times S times S, which is S cubed. So the volume of a cube is S cubed. Okay? So these formulas are the volume of a cube and the surface area of a cube. Does that make sense to you? All right. So, if I'm looking at, now sometimes the question, right? Sometimes if they tell you to optimize a pizza box and then you're going to make a pizza box into a cube, seriously, you could probably not here, or it's going to fit like this. It's not going to be. At this, how are we going to use this information that we have collected so far to the length, the width, and the height, right? So you're finding the side length. Okay? Good. So what did they give me here? The volume. So I know that the optimal dimension, so I'm looking for side length, yes? So basically, because I'm looking for optimal, I know it's going to be, yes? And I know that cube only has one dimension, which is S. So I'm looking for S. Correct? Yes. Exactly. Right? So I know my formula though. I know that the volume is S cubed. So can I use that formula to solve for S? Right? So all what I have to do here is I have to take the volume of a cube, which is V equals S cubed. I know the volume is 5,000. I need to solve for S. What do I do to solve for S? What do I do? Cube root. What's the opposite of cube? Cube root. The opposite, here's a lesson with opposite operation, right? I want to isolate for the letter, right? If I have, let's say, 36 equals, now this is side work, okay? 36 equals S squared, right? How do you get rid of S squared? What's the opposite of square? Square root, right? So you take the square root of both sides, right? Square root and square, they cancel each other, and then you end up with S. What's the opposite of cube? I'm just going to give you, I think 125. Okay. The opposite of cube is cube root. The opposite of any power is the root of that power. So if you have S to the power of 4, it's going to be 4th root. s to the power of 17, it's going to be the 17th root. It's always the opposite, the root of that power. Okay? How do you enter that in the calculator? That's your next question. In the calculator, it depends on the calculator. So if you look at this, right here. So if you do like third, right? So you're looking for the x root. Yeah. So the number first. No. Let me see. You should be able to if you have a shift button. Do you have any other like a reverse button? Any?
Sadly, no. I do have a better calculator.
Yeah. So I don't know how to do this one. Yeah. I'm sorry.
It's fine.
Sorry. So your cube is right here. So you just do shift cube. But if you're looking anything other than cube, like 4 or 5 or whatever, you just put, let's say if you're looking for 4, okay, fourth root, you do 4 shift this. Okay, that's fourth root. If you're doing for cube root, because your calculator has a cube already, you can do just this. Yeah, 50. I think it's 5,000. Yeah, 5,000. Okay. All right. Do we all have that calculator? All right. So you're getting rid of an exponent. You do the root of that exponent. Okay with that. All right. So in this case, right, because I have my exponent of 3, and I want to get rid of that exponent of 3, obviously all what I have to do is root 5, and that gets rid of 1. Okay? So the cube root of 5,000 was 17.1 centimeters equal to x. Okay? So that means I have now to record my answer, right? The box by how many sides do I report it to? 3, because it's a 3D shape, right? 3D shape, you report to 3 sides. So 17.1 centimeters by 17.1 centimeters. Volume, you start with the volume. So if the surface area, that means the unit has to be centimeters squared. So what is given to me in this case? Surface. So surface area is 45. I am looking for length, right? I'm looking for the side length. Remember, again, I see that word optimal, so I know I have to use a cube, right? So I can use the surface area with the surface area of cube. Divide by 6. I question is split for you. It's two separate parts. But I could eventually, one of the questions could be the surface area. But it's not. Volume of cube. The whole I know. I use so 649,461.9. Okay. The optimal volume, just determine the optimal volume. But I could ask you that question without asking you to find the dimension, but you still have to do both steps. Is that clear for everyone?